Assalamu alaikum. My name is Audri Thamid. My ID number is 2621537. Today I'm going to talk about usage of mathematics in computer science engineering and real life. There are three topics that I'm going to talk about: discrete mathematics and logic, algorithm and complexity, and cryptography and number theory. So our first topic is discrete mathematics and logic. Discrete mathematics deals with mathematical structures that are fundamentally separate and countable. As opposed to continuous mathematics like calculus, everything here works with distinct, separate values. Integrals, graphs, sets, logical statements. It is the backbone of computer science, cryptography, algorithm, and formal reasoning. Now comes our second topic, algorithm and complexity. Algorithms are step-by-step procedures for solving problems. Complexity is the study of how much time and space an algorithm needs as the input size grows. Together, they answer the fundamental question in computing. Now comes our second topic, algorithms and complexity. Algorithms are step-by-step procedures for solving problems. Complexity is the study of how much time and space an algorithm needs as the input size grows. Together, they answer the fundamental question in computing. Our next topic is cryptography and number theory. Number theory is the branch of mathematics dealing with integers and their properties: divisibility, primes, modular, arithmetic. Cryptography is the science of securing information using mathematical techniques. These two are inseparably linked. There is a paraphrasing by Carl Friedrich Gauss. Number theory is the queen of mathematics, and cryptography is her most powerful application. Modern internet, security, banking, messaging apps, blockchain all rely on number theory at their core. So these are the three topics that I talked about. Thanks for your time being here.
Assalamu alaikum. My name is Thamid Saleh. My ID number is 262155520. Today I'll talk about the uses of mathematics in finance and banking, engineering and medicine. In banking, on every transaction, interest and transaction charges are calculated based on algebra. Compound interests, loans, shapes, and saving shapes are also calculated using mathematics. In finance, risk models, statistics guide insurance, pricing, and investment decisions are made using mathematics. In medicine, exponential model track disease spread. Imaging relies on algebra. Lastly, in engineering, trigonometry, set angles, and proportions, construction and design are also based on mathematics. So everywhere we go in our life, mathematics is the backbone. Thanks for your time. Assalamu alaikum.
Assalamu alaikum. My name is Mohammad Zubair Khan. My ID now 262155342. Today I am going to talk about uses of mathematics in computer science and engineering and real life. I am going to talk about three topics: linear algebra, probability and statistics, graph theory and networks. Linear algebra. Linear algebra is basically the operating system machine learning runs on. Most of what happens inside a model, from a single linear resignation to a massive neural network, is vectors and matrix being transformed. Let me walk you through the core connections. Linear algebra is the mathematical backbone of machine learning. Nearly every ML algorithm underneath a sequence of vector and matrix operations. Here how the pieces fit together. Number 2, probability and statistics. Probability and statistics give machine learning its language for unnecessity. Every prediction model makes is really statement about probability, and every model is trained by treating data as samples down from some theorem describes that's the same pattern behind A/B-based analysis and online learning. Graph theory and networks. Graph theory gives machine learning a way to model relationships, not just isolated data points. Social networks, molecules, knowledge bases, and recommendation system, all neutrally gaps and the growing area of ML. Graph neural networks is built especially to learn from the structure. Here, what's the message passing?